Hello and welcome to the November edition of Mella Pawffice Hours. This webinar is Mella and QSM, Integrated Infection Testing for Faster Diagnosis and Treatment. In the next few minutes, we will discuss how the QSM OTTER is improving antibiotic stewardship for veterinarians by more accurately identifying bacterial infections. We will also talk about why it's necessary for pet parents to benefit from receiving the correct medication for their pets, and how we are working towards our goal of allowing all of our devices to work on any platform. To start off, I really just wanted to show off one of our very recent podcast episodes. That full episode does exist. It's 20 minutes long, and it's available on the Mella Moment Pet Health podcast for anybody to listen, today on your drive back home or your run or when you're walking the dog. It's just a bite-sized episode to kind of distill everything down.
Bacteria use these quorum-sensing molecules, and similarly, each bacterial species can detect, has evolved its own QSM. So it only detects that QSM, and they actually are able to coordinate all sorts of multicellular activities. So you think of bacteria as a single cell swimming around, but they actually live in communities and communicate and share resources and things. So it's that's been fascinating from an academic side. And when we figured out how unique these molecules are and that we have a way to detect them, the technology we use called electrochemical sensing, so similar to a glucose meter, we can detect the molecules this way. That's when I got the idea that this could be a really interesting sensor application. And just like glucose meters, they're really low cost and fast. We could do that for bacterial infections.
Yeah, so as the teaser kind of pointed out, and this is really a nice tie-in that we're QSM Diagnostics, and based on these quorum sensing molecules, we're really working on how to fundamentally change how bacterial infections can be diagnosed. And so I want to start with a little use case and talk about what our cartridge for our first instrument does and how it can work and why it's important. So really the bottom line is no one likes to wait for the correct diagnosis. And when it comes to bacterial testing in particular, those results are almost never available the same day because you still have to grow them on a standard culture plate. It takes several days for the colony to form, and then you have to run additional tests to identify what that colony actually is, and usually there's transportation involved. And so that's a particular test that doesn't get run as often as it should. And so in the example I'll be talking about, we're going to be focusing on dog ear infections, where you as a pet owner notice your dog scratching at its ear or shaking its head. And for a couple of reasons, usually everybody's busy, so they're not actually going to go to their vet the same day. You'll wait until you have some time. But part of the additional problem is now the veterinarians are incredibly busy through COVID and continuing on now. So you can't get in to see your average vet. And when you do, they'll try to do as much as they can. And they'll diagnose and they'll send you home with some medications that day. And part of the reason why is because if they see bacteria on the tests that they do, they can't identify beyond that during the visit. And that test generally costs $250. But in the last year, prices have been skyrocketing. So I've heard of people paying $350 to $400 for these kinds of bacterial tests. And the best practice standard is if you see bacteria in the clinic, you're supposed to send out for a culture. And we know this doesn't happen. And so we're trying to use our technology to be able to improve the standard of care. So diving into this in a little bit more detail, what happens, the veterinarian looks in the dog's ear, he sees inflammation, sees that it's potentially dirty, has exudate, it's pus, and this always gets done. It's relatively quick. What should be done as the next step is cytology. So you collect a swab sample. The technician or the veterinarian will put it onto a microscope slide, stain it, and look under a microscope and try to see what's there. And things like mites or fleas are easy to see. Yeast aren't bad, but then bacteria are an order of magnitude smaller than a lot of these other things, definitely an order of magnitude smaller than, say, white blood cells or red blood cells. And with a microscope in the clinic, when you're in a hurry, trying to be able to identify, well, is that a bacteria? And if it is, what's its shape? Is actually really challenging and takes some significant training. And combined with the limitations that are out there, it's only actually being done about half the time. And the medication's getting prescribed. And to send out when you see bacteria, that's almost never done on an initial visit. And our goal is to be able to identify those bacteria in the clinic without sending out and making this entire process faster, cheaper, and easier for the veterinary technicians and the veterinarians to get the right answers. So when we developed the technology, we started with a study because we're focusing on ear infections. And one of the things we wanted to see is, well, how good are the clinics at identifying what's actually on the swab when they do the cytology. And so we enrolled 9 different hospitals and specialty clinics, and actually the majority of these 300 samples that we got came from dermatology clinics. So these aren't general practitioners, these are people who are specifically trained at looking at ear swabs and wound swabs. They would look at it, they would score it, give us the results, and send in the swab to IDEXX Bioanalytics to do a culture ID. And we would then compare the results. And this was really surprising to us. So if you compare the cytology results, just saying how often was the clinic correct in identifying that there were rods on the cytology sample, accuracy 76%. They almost always, so about 93% of the time, did identify that there are bacteria. But the surprising part is they also really over-identified, particularly when it comes to rods. And part of the reason is rod-shaped bacteria, in particular if it is rods, if it's Pseudomonas, you don't want to miss that because that's going to be a really important bacteria that you want to treat accurately and require special antibiotics to really clear up. And they were overestimating very significantly. And so I can look into the breakdown of this. How did these numbers come about? So out of the 304 samples that were analyzed, basically 258 of them had noted rods on the cytology, and less than 200 of them actually had rods according to culture. They didn't miss too many, but there were some that were missed and some that were totally accurate. One of the things people mention is that the bacteria don't grow in culture sometimes due to shipping and things like that. We didn't have that problem here. Only 9 out of the 304 didn't grow anything. So we always had growth. But this is just saying that it's rods. Now, within rods, you could have things like E. coli, you could have Proteus, all sorts of things. How often was it actually Pseudomonas? And that's the next piece of information that we can get from this. And it turns out that only 29% of the time was it actually Pseudomonas when it was identified as a rod on cytology. So this really highlights the need to be able to identify Pseudomonas more accurately. And this is meant as an example. Obviously, you'd want to be able to identify all the different bacteria and not just look at ears. And our technology can do all of those things in the future as well. Otherwise, we wouldn't be here talking about it. And so this is the instrument, the OTTER EQ. where you're able to put that ear swab onto our cartridge in the clinic and get those results out, identifying with higher accuracy when Pseudomonas is actually present. It's the only test for an ear swab sample that will give you ID level information for Pseudomonas at the moment. How we're able to do this faster and more accurately, we don't wait for colony formation and chemical reactions of products. We're actually looking at these metabolites, at these quorum sensing molecules that the bacteria are secreting out. On that little cartridge is a series of sensors. The first one is for Pseudomonas. It reacts with these QSMs that are unique, and it measures a result. And so you get actually a measurement based on this biomarker for the Pseudomonas, and you can track that level. And so it gives you the concentration of that molecule that's present. And this is where our tie-in with Mella comes in, because right now you would go to our website and run this, and you'd get a PDF result out, and you'd have to process the samples. Why we're excited to be working with Mella is they'll be able to actually identify the patient and tag it and coordinate those results, and then get the final results into the medical records automatically. So this is the setup that goes into the clinic. Right now, it does still require some incubation to reach the sensitivity. To give you a sense of the size scale, this is the actual instrument. It's the size of a TV remote, and you get a little tube holder. So when you take the swab, you put it into the tube, you let it heat up for 12 hours. This Mella software will tell you when it's ready. You take a second swab, you rub that interface, you rub it on the cartridge, and it gives you an instant result in less than a minute, telling you the level of the Pseudomonas and the piocyanin that's present. Cartridges are recyclable, and we'll know when the tests are run. We'll be able to see all the real-time data. And obviously, so as I mentioned, this is for Pseudomonas for dog ears, but we have a number of additional cartridges that work on the same instrument that are in development that are going to be coming out next year and the coming years. So we already have identification for Staphylococci bacteria that's showing us real promise. And we plan to launch a full 7 pathogen test that'll check for all the common bacteria that you'd normally see on a swab or on a urine sample, and get all that information out. And you'll be able to just grab cartridges that'll check for different combinations of pathogens. So multiple things on one test. And we won't talk about it today, but one of the things we've also added in for clinics is when they collect those samples, they can send them to our lab, and we'll do all of the analysis. So we can do a cytology and the QSM tests ourselves. So that's another option that we have. And we have clinics that now are short-staffed, or if you're a mobile vet, you can collect a swab, send it to us. We'll do the cytology. We'll send you images of that microscope slide, but we'll also run the Pseudomonas test and get those results in addition. Or you can have the instrument and you can run it yourself in the clinic. And I'll stop there. That's kind of the overview of how the technology works and what we're offering. And I'll hand it over to Yale.
I just want to say, the moment that I had become aware of this technology that Ed was making, I was like, wow, this is the greatest innovation since, individually wrapped cheese slices in terms of bacteria. And I just realized that, as a company at Mella, we're not about creating walled gardens. We really would like to work with as many parties as we can. And so having a USB instrument, which is what they have, it made complete sense for us to have it as part of the integrated experience with Mella, just as the mail-in package. Let's say, for example, for a company that has a single source of pet records, a mail-in package integrate tie-in where they could order a test for their pets, where if they suspect an illness at home, also a great opportunity. Okay, so this is what, so I don't have the instrument with me. So because of that, I will show show this demo in 3 parts. Right now, what you see is the latest version of the Mella desktop experience. So so you have all of the instruments that we've shown in previous demonstrations, including the thermometer, the scale, of course, the tape measure, morphometric tape measure, which we showed last time, and now the Otter EQ is the latest addition. So you'll see that each instrument has its own color scheme. That is by design, so you can at a glance know exactly what you are using. So what the team and the development team at QSM has given me are some serial numbers that work for registration. So I'm going to just type in the serial number here, and I click next. When I do that, it says user registered successfully on practice test clinic. Now the practice is already activated. The next thing it's going to ask me to do is plug in an Otter EQ device. Okay, so the next part is, of course, this video. So this is from our development team, who has been working with their development team. So in this case, they put in a serial number that is wrong. Let's say 1, 2, 3, 4, 5, 6. They'll try to register it, but then what happens is it'll say this instrument doesn't exist, right? So if somehow they have something that is not valid, then it won't let them register. You'll see that here it goes this. They actually physically plug in the device. Of course, I can't show that, but this is where it goes to the next screen, and it tells you to swab the pet's ear. So this is as far as we got in terms of integration. The rest will be completed sometime in December, but I will go ahead and show everyone what the rest of that looks like. So here are the rest of the screens that we've designed and what that looks like. So the next thing that happens is once it's been registered and you're at this stage, you actually swab the pet's ear. Here, you swab the pet's ear, and then you put the sample into the solution, and you swirl it into the solution. Now you'll see that these are the instructions that Ed had just talked about verbally. We actually built it into our application so that anyone can be trained within 10 minutes how to do this. So instead of having cytology, which requires you to look at a microscope, you don't have to do any of that. You just put the sample in the solution, and then you break off the stem and insert into the gel of the collection tube. So you break the stem off, then you seal it, and then you assign the patient ID, which is right here, to the patient, and it's going to print a label of which you can then affix to the collection tube. So this is all done inside the Mella software. And the next thing you do is you just put it into the incubator. That was part of the kit that you receive, and then it automatically starts a timer. After the timer is ended, then it will ask you to put a new swab into the sample and collect it, and then put it into the microchip. And then once that happens, of course, you get a result coming from the QSM backend. So all of this, of course, will be done straight inside of the Mella, the Mella desktop application, which again, we're very excited because we are now incorporating external instruments as a part of our strategy. And we're really glad to have Ed be such a great partner. His team has created the perfect SDK for us to be able to use this seamlessly. So if you have a device, you just plug it in and it'll just automatically work. So that's where we are right now.
The serial registration is important because eventually there are going to be other companies and knockoffs potentially. You want to know exactly that who received an instrument and that they're registered. It's one of our instruments to have that there, but it also allows us to then track on the back end, as I said, that it's a real user and what the results look like. I love what Mella was able to do with their team to show all the additional pictures. Definitely one of the things that everybody says is like, well, is it my left or the dog's left when you're talking about your samples? And they have a nice little image to kind of help guide through that and put all the pieces together and print out automatically what patient it's assigned to. So if you see multiple ear cases in a day, you're less likely to have an issue with getting the results out and plugging all that back in. So it really is going to help further streamline and really, like Yale said, let any person with just a few minutes of training run our test accurately and be able to trust the results.
Yeah. I mean, I don't want to say that Ed has invented the sous vide oven, the app-controlled sous vide oven of a bacterial detection test. But the truth is, it is like a sous vide oven. You let it incubate for 12 hours, and then you take just a drop, put it onto the microchip, and then you magically get the results without having to use any microscopes. So again, this will be the future of detection, and we're just glad to be a part of this early effort.
Yeah, and as soon as we roll out the next version, the goal is to get rid of even that incubation. And we've seen this on some of urine samples, and we already see it on more serious infections. You can see it instantly, so you wouldn't even need to do the incubation step. You would just rub, mix it in our solution, put it on that. And the goal is to be able to have this ID during the visit. And that's very much an option, and it's going to get rolled out next year on this. So that'll be the next iteration for these technologies.
Thank you for watching this edition of Mella Pawffice Hours. Don't forget to catch us live on the second Tuesday of every month at 1 p.m. Central, or watch the rest of the recordings at www.mella.ai/webinars.